Hello my dear students, in the last lecture we saw some of the theory part of equilibrium of forces, and also we saw the Lami's theorem, the concept of Lami's theorem, and we solved two problems. Now we'll solve some more problems on that chapter. Okay, so question number 3. So we have to find the tension in the string. So T1 and T2, we have to find the tension. So this is the problem. Okay, so this is one type of the problem. Okay, so now we have to take the free body diagram of this. So what is the free body diagram? So this is 20 kilonewton. It may be the weight of that figure or that object. Okay, 20 kilonewton, and here this is T2, and here this is T1. I am writing the free body diagram at A. So this may be the A. So now they have given that this is 30 degree and this is 45 degree. So this is 45 degree, this is also 45 degree, and this is 30. Because of this is 30, so 90 minus 30, it will be 40. Okay, then we have T1, is the weight force W, 20 kilonewton, and T2. So here you can see T1, T2, and weight is 20 kilonewton. So 40 plus 45 is 105 degree. So we have three forces, and we can that all are in coplanar concurrent forces. So we can use our Lami's theorem. What is Lami's theorem? So this force divided by the opposite angle, sine of opposite angle. So 20 divided by sine of 105 degree, which is equal to T1. T1 equal to sine 135 degree, opposite of 90 plus 45. So this is 90 degree and this is 45. 90 plus 45 is 135 degree. Angle is 135. T2 opposite by sine of 90 plus 30, that is 120. So using Lami's theorem, 20 by sine 105, T1 by sine 135, T2 by sine 120. So T1 is equal to sine 135 into 20 divided by sine 105. You will get 14.64 kilonewton. Similarly T2, so T2 is equal to sine 120 into 20, just cross multiply, divided by sine 105. You will get the T2 as 17.93 kilonewton. Now we'll see the next problem. Here I will show how the problem is solved. You solve this problem. The next problem, you solve it. See here, the system of strings and the forces are in equilibrium. Determine the forces in the string. The system of strings and forces are in equilibrium. So this figure is in equilibrium. Okay, so T1 force is there, T2 force is there, and here 2 kilonewton force is there, 3 kilonewtons. Okay, now T1, T2, we have another two forces, 3 kilonewton force and 2 kilonewton force. Okay, what we can do here, we should find theta 1. So what is this theta 1? So theta 1 is in this triangle, right? Okay, see that only, this triangle theta 1. So theta 1 is equal to opposite by hypotenuse, or hypotenuse is this, as this is the right angle triangle, this is 45 degree, 90 degree, sorry. What we can do, and theta is equal to, or this, what we know, and theta is equal to what? Opposite by adjacent, right? So what it form? So theta is equal to, see here, theta is equal to tan inverse of, here theta 1, tan inverse of opposite tan 1 divided by 2. So we'll get the theta 1 value, that is 26.56. Same for theta 2, this triangle theta 2, 1.5 plus 1, 2.5, 2.5 by we'll get 51.34, 26.56. We got theta 1 and theta 2, and we have four forces 1, 2, 3, 4. So we can't use here Lami's theorem, but we can use the concept of equilibrium of forces. As it is in equilibrium, what were the conditions of equilibrium? Summation of all the horizontal forces equal to 0, summation of all the vertical force is equal to 0. So apply this condition. How to apply? So summation of all the horizontal forces is equal to 0, taking left to right as positive. Okay. Now what are the forces which are in, what are the forces? Okay, horizontal forces. So here we can see 3 kilonewton plus, then what we can see, 3 kilonewton, we can't write plus. So this is only one force which is in this direction. So next we can take this T2. Okay, T2. So you just resolve this force. So what is this? This is T2 sine theta. Okay, what is this? T2 cos theta. So for this big triangle, which theta we have to take? Theta 2 we have to take. So what it happens? 3 minus T2 horizontal force we want, cos theta 2, then minus T1 cos theta 1, then which force? Okay, this much only, which is equal to 0. So 3 T2 cos theta 2. So we know the value of theta 2, 3 minus T2 with some numerical we will get, minus T1 with some numerical we will get. Take this as 1. Okay, take this equation as 1. Now summation of vertical forces taking upward as positive. What are the vertical forces? So here 2 kilonewton is there, that is in downward direction. So minus 2 kilonewton plus what? T2, we had resolved it. What happens? T2 sine theta 2. Similarly T1 sine theta 2, that will come under T2 sine theta 2. Okay, is equal to 0. So we'll get two equations, equation 1 and equation 2. So this is the equation we will getting. If you follow what I said, you will get these equations. Summation of horizontal force equal to 0, summation of vertical force equal to 0. If we do, we will get this equation. Then solve these two equation, we will get T1 as 2.76, T2 as 1 Newton. Okay, this was about the fourth problem. Okay, don't see this all. Okay, it will be confusing to you. Just you substitute in the conditions of equilibrium, that is summation of horizontal force is equal to 0, summation of vertical force is equal to 0. You will get two equations and solve that equations, you will get the value of T1 and T2. Now fifth problem, determine the tension in different parts of the string as shown in figure. So they have given a figure, you have to determine the tension in different parts. So we have to find T1, T2, T3 and T4. Okay, so as it has many positions, so D, B, okay, we can take the help of free body diagrams. So I'll show you how to draw the free body diagram at D. So take a point, so this is the point D. Now so T4 is there, no, just write T4. then 600 Newton is there, 600 Newton. Next T3, T3. So being in the coordinate axis, so this is 30 degree. Okay, so here this is 30 degree. So now if this is 30 degree, what about this 90 minus 30? 90, 30 is another remaining is, this is 60. Okay, 60 plus 30. Now this is 30 degree. Okay, what about this? If we have two parallel lines here, okay, wait, parallel lines. So here we will take a parallel line at D and we will take a parallel line at B. So this is 30 degree. Okay, so what about this? This is also 30 degree, this angle, because it forms in alternate angles. This is 30 degree, so this is also 30 degree, since this is also 30 degree. Then what is the angle here? 90 minus 30, which will be 60. So we found all the angles, right? This is 90, this is 90. So what are the unknowns? T3 is unknown, T4 is unknown, we have 600. So what we can apply? We can apply Lami's theorem. Three forces are there. Okay, three unknowns are there. We can apply the Lami's theorem. See here what I drawn the FBD, same. So this is the position D, T4, T3. This is 30 degree and this 30 degree by the alternate angle concept, 60. So what? 600 by this total angle 60 plus 30, which is 90 degree, is equal to T4. T4 divided by this angle 30 plus 90, 120. Next T3 divided by 150. So equate them, apply the Lami's theorem concept and equate them. So T3 is equal to sine 150 is equal to T4 by sine 120 is equal to 600 by sine 90. Now equate any two. So T4 into sine 90, 600 into sine 120. When we cross multiply, we will get T4 is equal to what? 600 into sine 120, okay, into sine 120 divided by sine 90. Okay, we will get T4. Similarly, when we cross multiply this T3 and so T3 is equal to 600 by sine 150 divided by sine 90, we will get T3 value as 300 Newton. T4 is 590 Newton. So solve it. If you solve only, you will not get confused. You will get the answer. Okay. So we found T3 and T4. At D we have found. Now next we have to take the FBD at B. So FBD at B. So this is the point B. So this is what? T2. Then what are the forces are there? Then it is 400. Okay, 400 Newton. So what you are seeing, first write those 30 degrees there, then here T3 is there. Okay, another force T3, that to how much it is? It is also 30 degree. So three forces, T1 400 Newton one force, T3 one force, T2 one force, right? Then here T1 also is there, correct axis we have also T1. So how much force we have? T1, T2, T3 and 400 Newton force. Four forces we have in the FBD at B. So what we are doing? So FBD at BC here, T2, T3, T1, 400. Okay, as this. So now we can't apply Lami's theorem because we have four forces, right? Now we can apply the concept of equilibrium, that is sigma h equal to 0 taking left to right as positive. Okay. Now what in this type of force, the we have to resolve the inclined forces. So T2 is the inclined force. So what it will be? This would be T2. So the angle is here. So adjacent to that angle, that will be T2 cos 30 degree. This will be T2 sin 30 degree. So we have another force T3. T3 will be what? Another force T3 when we take T3. So T3 cos 30 degree, and here T3 sin 30 degree. So we have dissolved T3 force and T2 force. Now what we have to do? Just apply the sigma h equal to 0 taking left to right as positive. So what are the forces we will get here? See, minus T1. Okay, left to right is positive because it is right to left. See the direction. Okay, minus T1. Okay, plus T2 cos 30. Okay, plus T3 cos 30, but we know that T3 value as 300 as we solved here before. T3 value, so take T3 cos 30 degree, which is equal to, and it equate it to 0. We will get an equation T1 minus T2 cos 30, that is equal to 259.8. Take it as equation number 1. Next, summation of vertical force equal to 0. Which are the vertical forces? Take only that forces and equate it to 0, taking upward as positive. So which are the forces coming upward? Take them as positive, and the forces directing downward take it as negative. Okay. Now, so we can see here 400 is the vertical force, and T3 sin 30 is a vertical force. T2 sin 30 is a vertical force. Now summation of V is equal to 0. So T2 sin 30 degree, so it is positive. Okay, T2 sin 30 degree minus T3 sin 30 degree minus 400. So T2 sin 30 minus 150 minus 400. So what is this 150? T2. Okay, summation of this sin 30. So 300 sin 30, no, sin 30 is half, no, 300 into half they have done. This is 150 minus 400. So we'll get an equation for T2 also. Then solve equation number 1 and 2. You will get T2 as 1100. What is that? Newton. Don't forget to write the unit. T1 is equal to 259.8 Newton. So in this equation now T1 is equal to 1472.2 Newton. So this was about this problem. So just you have to take the FBD, free body diagram, wherever they have given the force. Then there are more than 3 forces. Use the concept of equilibrium, that is sigma h equal to 0, sigma v equal to 0. Or if 3 forces are there, then go for Lami's theorem. Okay. So this another problem we have. A force P is applied on the tension in the string is equal to 600 Newton. Determine the magnitude and direction of the P. We have to determine the magnitude and direction of P, whereas we have given T is equal to 600 Newton. So here also T is equal to 600 Newton. So what we have to do? We have to take a FBD at node A. If we take the FBD, we have to resolve this force as in the horizontal and vertical direction. This force also in horizontal and vertical direction. Okay. horizontal and vertical direction. So T, okay, here two forces, one force here, one force here. So you solve it, okay, you will get the answer for your reference. It is already solved it. Then we'll go to the next problem, which is this one. Find the forces in all the bias and the load W1 to keep the system in equilibrium. So we have to find the force in W1 so that we can keep the system of forces in equilibrium. So because to keep the system in force in equilibrium, so what we have to take the condition sigma h equal to 0, summation of v equal to 0. So see the system of forces, we can take FBD at B and FBD at C, two nodes are there. So FBD at see here, we have T3 force, W2 force, and we have another force here, this is T2. So see here T3, so angle this is 30 degree, so this triangle 30 degrees, so parallel. So this is alternate angle, this is 30 degree, so same 30 degree is written, 30 degree. If this is 30 degree, 90 minus this is 60 degree, okay. So this is a 90 degree, so 90 plus 60 is 150. First you determine the angles after writing the force, okay. Then this is W2 is 1000, opposite to that 150 degree, okay. T3, this is 90 degree, this is 90 plus 30 is 120 degree. So what we can write here from FBD, this W2 1000 by sine 150 opposite angle, that force is equal to T2 opposite angle, what is this, 30 plus 90 sine 120, which is equal to T3 by sine 90. Same as we solved before, solve for T2 and T3, you will get the values at 2000 Newton, 1732.0 Newton. So after taking the FBD at C, take the FBD at B, what we are getting, if we take the FBD at B, so T2 force, then here T1 force, here W1 force, okay. T1, T2, W1, two unknowns, angles calculate here, what are the angles between the other two forces, apply Lami's theorem, we'll find the values for the necessary forces. So T1 by 90, T1 by sine 90, W1 divided by sine 120, and this T2 we already solved it, the T2, so T2 divided by this angle 60 plus 90 is 150. So we'll get the values as T1, T2, T3, W1. So W1 is the angle, W1 is the force which keeps the moment in. So W1 is 299.91 is the force which keeps the system of forces in equilibrium. Then we'll solve another problem. So it is also same problem as we solved before, but here what we have to take, for confusion they have given here, see here in the figure the B position, B is horizontal and the pulley is frictionless. Here the pulley is frictionless. If the pulley is frictionless, so they have given T4 as 100. T4 is the extended part of the T3 after this pulley, and which is taking a weight of 100 Newton. If T4 is 100, because the pulley is frictionless, the T3 is also 100. So T3 force is also 100. So for this the value was given, that since the pulley is frictionless, okay. So same T3, take FBD at C and FBD at B, solve for the forces, you will get the answer. Now here find the value of W which is required to maintain equilibrium configuration as shown in figure. So same here also, take the FBD at A. Okay, FBD at A. So here you have to take FBD at, after taking FBD at A. So you have to find the angle. How we will find the angle? I'll show you. Wait. FBD at A. Okay. This is the T1. This one. Let this be the T. Okay. W. T is equal to W. T is equal to W. Okay. Fine. Then we have to find angles so that we can apply the Lamis theorem. Okay. So this is forming a triangle, right? Now this is 1.5 meter. What we want? We want this theta. So the what is this distance? This is 0.5. Okay. So this becomes the right angle triangle. Okay. So theta is equal to adjacent opposite by adjacent. Okay. Opposite is 1.5 divided by 0.5. So theta is equal to tan inverse of 1.5 divided by 0.5. We'll get theta as 18.43 degree. So after getting theta, just find other values. In the quadrant, the value is 90. So here 90 minus 18.3 is this angle. So 19.18.3 is this angle. So because it is 3 meter and this is 0.5 meter, it becomes isosceles triangle. We can, then the theta will be same for both the side. Okay. Then by Lamis theorem, 100 by sine 143.4, then W by, then this T divided by 108.43, next this by 108.43, we will get W as 158.15 Newton weight. So this is also same. Find the value of W1 for equilibrium condition as shown in figure. This figure also I will leave you for the assignment. Okay. Now we'll see the ninth one problem. What is given? A 3 kilonewton crate is to be supported by the rope, which is the 3 kilonewton. This is the 3 kilonewton crate, which is supported by the rope and pulley arrangement shown in figure. Determine the magnitude and direction of the force T. Where is the force T? Here. The force T. Okay. Which should be exerted at the free end of the rope. Which should be exerted in the free end of the rope. Exerted at the free end of the rope. Okay. So see here. They have given the distance here 3.6 and this distance as 1.05 meter. So if take BD at this O, okay, what? So we will have force T, okay. Then we have weight that is 3 kilonewton, okay. Then we have another force here. The T is same. We have two ropes, okay. So for problem we'll take as 2T. We'll add the 1T for this one, 1T for this one. So we'll take as 2T. Okay. Now we will find the angles. So this is the alpha. So see here from this triangle. So they have given the values for this 1.05, 3.6. So theta is equal to tan inverse of 3.6 divided by 1.05. We'll calculate theta will get as 73.7 degree. After getting the alpha value, okay, just apply the equilibrium forces, that is sigma h equal to 0, summation of v is equal to 0, because here the intensity which we draw no, here intensity was 2t, we have added that so that we can't use the Lamis theorem because the intensity of one force is bigger. Okay. greater. So 73.7, this is the FPD. Okay, see here. So this is what, 90 degree, and this is 90 degree. This is 73.7. So 90 minus 73.7 will get here value if you want to apply Lami's theorem, or we can apply the direct conditions of equilibrium. How? Sigma h equal to 0, sigma v equal to 0. Here the value of t, which are the value of t if it is sloping, or if this is in inclination, we have to resolve the value of t. So we'll resolving. So this t I am resolving. So this becomes t cos alpha and t sin alpha. Similarly, this 2t force, okay, this 2t force in the upper direction, it will become 2t sin alpha, and here 2t cos alpha. In horizontal direction it will become cos alpha, in vertical direction it will become 2t sin alpha. So now you just apply sigma h equal to 0, taking left to right as positive. So here they have taken separately and they have calculated. You can do this. I'll tell you in one method only without separating out. So here, so sigma h equal to 0, taking left to right as positive. So take t cos alpha. Okay, all the horizontal forces you have to take. So t sin alpha is vertical and 2t sin alpha is also vertical. Now this force minus 2t minus 2t cos alpha is equal to 0. This is for horizontal forces equal to 0. Take this as equation number 1. Now vertical forces equal to 0. Vertical forces, which are the vertical forces? Here 3 kilonewton is one vertical forces, t sin alpha is another, 2t sin alpha is, 3 forces are there, vertical forces. So 3 kilonewton is downward. So for upward we'll assume upward as positive. So what are the positive? 2t sin alpha. So 2t sin alpha plus t sin alpha minus 3 kilonewton is equal to 0. Take this as equation number 2. Now solve for what? Solve this both equation to get the t value. Okay, here t cos alpha minus 2t cos 73.7. Okay, here we can find the alpha value by the equation number 1. We can find this alpha value, that is t cos alpha is equal to, this will go that side, 2t cos alpha. So tt cancels, so alpha is equal to cos inverse of 2 cos. You just solve it. So first equation will become this one, t cos alpha minus 2t cos 73.7 is equal to 0. So alpha is equal to 55.9, and by second equation you will get the value of alpha. After finding the alpha value, you just substitute the alpha value in this value, sin alpha value. You will get the t force, that is 1.09 kilo Newton. Just solve once by method which I had told, you will get the answer. Fine. Now let us go to the another problem. Okay, this one is a sphere of 100 Newton is fitted in a right angle, not as shown in figure. Determine the reaction at A and B. So you take just FBD at node O. Take FBD at O. Take this force as force coming from this. So the where there is a contact, there will be a reaction. See a node RA. This is the RA. So in this direction only they have taken here. We can take RA reaction, and this reaction RB we can take here. RB downward force is 100 Newton. So FPD at O1 they have taken. So apply Lami's theorem. By this way, we can find the reaction RA and RB. We'll solve the next problem in next lecture. Thank you.